Same idea. Find, use the sum and difference identities to find the exact value of tangent of 7 pi over 12. Okay, we talked about the 12ths the other day, but remember how this works. You're just counting to figure it out. Okay, so the first thing you want to do is change that to degrees. We look at our unit circle and use our brains and figure out that it matches up with 105 degrees. Okay, then just like before, we want to think about two angles that either add or subtract to get us 105 degrees. So we look at our unit circle. I need to figure out two angles that either add or subtract to get 105. 45 and 60 could work. Anybody come up with anything else? About 135 minus 30. Doesn't that get you 105? Yeah? Which of the two do we want to pick? The first one. Okay? We talked about it a long time on Friday. We said this, though. We want to avoid, on a tangent problem, you want to avoid 30 degrees at all costs. It makes the problem extremely difficult if you have a 30 degree or if you use 150 degrees as well. Just don't use them. Figure out a way to do it another way. Okay, so we decided tangent of 45 plus 60. That'll get us what we need to have here. Okay? Next thing, we look at our sum and difference identities. Use the sum and difference identities to figure out which formula we want to use here. So we did tangent and we're adding. Which formula does tangent and adding? 1, 2, 3, 4, 5, 6. 3. Formula 3 says tangent alpha plus beta. So it says we're going to take tangent of alpha. What's my alpha going to be? 45. So tangent of 45 plus tangent of beta, which is 60, over 1 minus tangent of 45, tangent of 60. Questions to that point? Now we're going to do it. It says find the exact value. That means use our unit circle. So we're going to go to 45 degrees and decide what tangent is at 45 degrees. So go to 45 degrees. Would do y over x. What do I get at 45 degrees? Y over x. Square root of 2 over square root of 2, which gets me 1. So that's 1 plus. I go to 60 degrees. I'm doing y over x. So I get what when I take y over x? Radical 3 over 1, or just radical 3. If you're ever doing this problem and you get 1 over radical 3, you made a mistake. You picked the hard one. Go back and find a different way of doing it. That's why we avoid 30 degrees, because you'd get 1 over radical 3 and it'd be ugly. On bottom, it says take 1 minus tangent of 45 and tangent of 60. Well, tangent of 45 was 1. And tangent of 60 was radical 3. What happens when I multiply those two together? Radical 3. Okay, we get to this point. In a perfect world, we'd be done there, but we're not. Okay, it's a tough one. What do we not like about this problem right now? Radical on bottom. We don't want to have a radical on bottom. We need to change that. So we talked about on Friday, what do I need to do with this to get rid of the radical in the denominator? Multiply by the conjugate. Okay, very good. We multiply by the conjugate. Remember what that means. When we talk about a conjugate, we only care about the denominator. Okay, so when we talk about a conjugate in this problem, we have a binomial on bottom that we want to get rid of. I do not care what that top says right now. Okay, don't look at the top. That's not what we're looking at. To do a conjugate, we're just looking at the denominator. It says 1 minus radical 3. The conjugate of your denominator is going to look exactly the same, except we're going to change the sign in front of the thing we want to get rid of, which in this case is the radical. So instead of 1 minus radical 3, it's going to be 1 plus radical 3. And if I put that on bottom, if I'm going to multiply by that on bottom, what's going to go on top? Same thing. Whatever you multiply the bottom by, the top by as well. It's whatever's in your denominator, but instead of the minus sign, we're going to change it to a plus. If it said plus, it'd be a minus sign. Now we can solve it. Question so far. This is the long one. Get used to it. Put on your big boy pants and figure out what's going on. Here we go. From here, we need to FOIL. It's ugly, but every single time we do this problem, it's exactly the same. We're going to FOIL the bottom first. 1 times 1 is 1. And I'm going to FOIL 1 times radical 3. 1 times a positive radical 3. Positive radical 3. Then I'm going to do the second thing. So negative radical 3 times 1. And negative radical 3 times positive radical 3. Negative radical 3 squared, which is just negative 3. If you did it correctly, what's going to happen? The middles should cancel. We don't want to have radicals anymore in the bottom. The whole reason we multiply by the conjugate is so there's no longer radicals in the bottom. We just did that. Now it says 1 minus 3 on bottom. So my bottom is going to be negative 2. On top, we're going to FOIL again. So 1 times 1 is 1. 1 times radical 3 is radical 3. Radical 3 times 1 is radical 3. And radical 3 times radical 3 is positive 3. So on top, I've got two things here, really. I've got this 1, and I've got that 3 that I'm supposed to add together. What happens when I take 1 plus 3? Okay, then I've got this radical 3 plus that radical 3. You have one radical 3, and then you have another radical 3. How many radical 3s do you have? 2 of them. Okay, you have one, you're adding another. It's like x plus x. X plus x is 2x. Radical 3 plus radical 3 is 2 radical 3s. Then to finish this problem, what do I still have to do? Simplify. I got to take that divided by negative 2, and I got to take that divided by negative 2. Take both things and divide them. So 4 divided by negative 2 gets me what? Okay, that's great, but I have to divide this by negative 2 as well. So negative 2, or 2 radical 3 divided by negative 2. Negative radical 3. That is my final answer. It is a long problem. No one is saying it's not. But every single time we do a tangent or a cotangent problem, it looks exactly the same. You're going to have the same FOILs with 1s and radical 3s, and you're going to have the same answer. The only difference between this answer and any problem we do is sometimes it'll say positive, sometimes it'll say negative 2. Sometimes it'll say positive, sometimes it'll say negative radical 3. But other than that, they all look exactly the same.